Hello, everyone. My name is Andrew Pippo, and for the final project for CS3003, I will be doing the explanation of the Kotlin programming language alongside what coroutines are and how the Kotlin programming language and coroutines work to ensure more functional applications, like essentially writing better code, better applications, everything to that extent. So to get started here, what Kotlin is that it is a modern programming language. It happens to be open source, statically typed. It does target specifically with JVM, Android, JavaScript, WASM, and native. It is considered like other programming languages to be object oriented. However, it also does have the functional constructs, so you can also consider it a functional programming language to some regard with those constructs. And actually, what is unique about Kotlin is that it is essentially intertwined with Java, interoperable, I should say, which means that the way that Java compiles is very similar to how Kotlin compiles. And in fact, Kotlin is just an improved version of Java. And if you were to go into an IDE like Android Studio, to where you can develop Android applications using Java or Kotlin, you can convert it from one language to the other. Commonly, you convert the Java code to Kotlin, but you can also do it vice versa, most likely. And when I mentioned that Kotlin is an improved version of Java, I mean that it happens to be a lot more concise, more type safe, smart casting. Excuse me. It has the usage of higher order functionality, and it also has extension functions, lambdas, everything like that to allow more expressive code to be written, allow the opportunity for facilitation of the creation of DSLs. And essentially, it just handles the execution, it handles the behavior more appropriately, a lot better than Java or the older programming languages. And as I've mentioned, Kotlin is used for Android development. If you were to go to Google's website or the official documentation, they really are starting to push for Kotlin to be used for Android applications, as it does like pick up what, say, Java or C++ or other programming languages may lack. And since it is like intertwined with Java, it behaves similarly. So you can use it for other developments like multi-platform, native, websites, desktops, or even server sides because of how similar it is, especially like its syntax, all of that. Yeah. And to go over what coroutines are real quick, it is a program component, not specific to Kotlin. Really, you can see it in most modern programming languages, but it is basically a program component that allows the executions of asynchronous code or just code in general to be suspended and resumed. And it's basically the subroutines that are utilized for multitasking, and that's where the asynchronous comes in. Because conceptually, coroutines act like code running on the main thread. However, they are not attached to any particular threads, which means they are designed to be lightweight, to which not being attached to the main thread, it allows it to basically run those tasks, those lines of code without necessarily blocking the main thread. It would memorize the memory leaks, allows cancellation support, all of that to ensure that the application code does not become unresponsive and possibly crash or cause some bug or unintended behavior. And when it comes to Android development or really other types of development, it's just a simplified version of running code asynchronously. To show you what it kind of looks like, these are a couple examples that you can find on Google's website. Just a quick Google search, it pulls up like these example codes. So you can see you do have like a main function in this case to where it does call launch, to which it launches the brand new coroutine and allows other code to continue on as if it's not affecting anything at all. And basically this simulates a 1 second delay to which it will print hello first before printing out world. So basically both things happen at the same time to where it'll print out hello and it'll print out world at the exact same time. Of course, it'll happen 1 second later for the world since there is a delay in there. However, it is not blocking the actual thread itself, so it was able to execute within a second of each other as intended. And similarly with example 2 here, you do have the launch again, but also you have a suspension function called do world. And basically this does a similar thing to where it'll print out hello and it'll print out world, except it does suspend to print out world before it continues with the remainder of the main thread functionality, of course. And what I did to even highlight this further is I've developed a Android application. I do have a little bit of a emulator, I should say, that will show 2 stopwatches and alongside a 1 second simulated task that will run alongside the actual main activity code, starting to run and update the stopwatches as it acts like an actual stopwatch and it updates this screen every 1 second. So to get over this real quick. There we go. So to show you the code here real quick. So we do have the main activity code here, to which it creates what you see over here, the buttons, the stopwatch functionality. And ideally it will basically this was still running, hilarious. So basically the idea is if you hit the start button, it will update the time down here to every second. So it'll be 1, 2, 3, and it updates every second. And that's on the main thread, the main activity of this code. Additionally, I do have 2 classes here, one called no coroutines and one called coroutines. Original, isn't it? So the no coroutines is basically the simulated 1 second extra task that will be running alongside starting the stopwatch. And it'll be running with the thread, so it will be attached to a specific thread, and it will attempt to run at the exact same time. And this first start button up here will run both at the same time. So if you were to click on this, so it does start the stopwatch as expected, and also this has printed out the expected results. So we're going to stop this real quick. And if we go down to our logcat here for Android Studio, you can see down here that using the thread to run both tags, it has taken 1.053 seconds, which is honestly not a lot. However, you also will notice that it has skipped several frames, and it does give you the warning that it may be doing too much on its main thread. The main thread can only handle so much code execution, at a time. And if you put on too much, it may be overwhelmed and it could cause the unresponsiveness as it tries to attempt to do everything at once. And depending on the specifications of your computer or of the program, all of that, it could honestly crash the application or code that you're working on. So this is why there's the coroutines one where it uses the asynchronous, to which it won't be attached to a specific thread, but it'll be running in the background. And you'll see some differences here when I run the second button here, which is right down here. So it does run the second stopwatch as expected. And we're going to hit stop. What you notice is that compared to this, where it has thread and it runs the do work, which is up here, this has a similar do work, but it uses asynchronous and it uses the suspension functionality. You'll notice that with the coroutine instead of the thread, it is taking less time. Instead of the 1.053 seconds, it is 1.016, which shows how the coroutines are more lightweight and it's not being attached to a thread. It takes less time to execute code and allows the app to give a better user experience, and you won't notice as much of a lag or of any basically blocking of the main thread. I mean, you notice it actually skipped a little bit less frames. And you can see in like previous testing, initially it skipped like 65 and it dropped to 60. It pretty much varies, but essentially the general trend is that with coroutines, it does run faster and it does not skip as much. It's not a strain on the main thread. So that is in fact coroutines and how, in a sense of Kotlin, you can use it to run an application in this regard. For my example, they have like a stopwatch functionality, and then you have some other task that you use, like, oh, I need to do this, which I need to also have the time showing for. Or really any application to where, in a practical sense, you have to have two things running at the same time. Maybe you have to have like two stopwatches going at the same time, which both of these are running asynchronously or using coroutines, so it happens to be, so that it both updates the time at the same time without too much on the main thread. So that will do it for my presentation, and I will show you the sources here real quick. I'd say there's a lot of the main documentation for Kotlin online you can find. Android developers has a lot on Android code. That's where I got a lot of this from. And based on my experience too, as a co-op working for a small company, I've been doing a lot of Android development, and I've utilized asynchronous programming and coroutines, and it made my application a lot more operable. So that will do it, and I hope you all have a great day. Stop recording.